Hello everyone, we are going to learn about elementary properties of a ring. Theorem: in a ring are the following results solved. Number 1, a dot 0 is equal to 0 dot a is equal to a for all a belongs to R. Number 2, a dot minus b is equal to minus a dot b is equal to minus of ab for all ab belongs to R. Number 3, minus of a into minus of b is equal to a into b for all a b belong to R. Number 4, a dot b minus c or a into b minus c is equal to a into b minus a into c for all a, b, c belong to R. Proof 1. We have a dot 0 is equal to a dot 0 plus 0, since 0 can be written as 0 plus 0. That is 0 is equal to 0 plus 0. This is equal to a dot 0 plus a dot 0 by left distribution law. Implies that 0 plus a dot 0 is equal to a dot 0 plus a dot 0. As a dot 0 belong to R and 0 plus a dot 0 is equal to a dot 0. So here we can add 0 on the left hand side. So we get 0 plus a dot 0 is equal to a dot 0 plus a dot 0. Now R is a group with respect to addition, that is R together with binary operation plus is a group. Therefore, applying right cancellation law in R, we have 0 is equal to a dot 0. If we apply right cancellation law, then a dot 0 and here a dot 0 will be cancelled out. So 0 is equal to a dot 0. Similarly, we have 0 dot a is equal to 0 plus 0 dot a, since 0 is equal to 0 plus 0. This is equal to 0 dot a plus 0 dot a by right distributive law. Implies that 0 plus 0 dot a is equal to 0 dot a plus 0 dot a. Again, by applying right cancellation law for addition in R, we have 0 is equal to 0 dot 0. Here 0 dot a and here 0 dot a are cancelled by right cancellation law in the group R plus. Thus we have a dot 0 is equal to 0 dot a is equal to 0 for all a belongs to R, which proves the first part. Second, from 1 we have a dot 0 is equal to 0. So a dot minus of b plus b is equal to 0, because minus of b plus b is equal to 0 in R. Implies that a dot minus of b plus a dot b is equal to 0 by left distribution law. Implies that a dot minus of b is equal to minus of a dot b, since in a ring a plus b is equal to 0, implies that A is equal to minus of B. So A dot minus of B is equal to minus of A dot B. Similarly, we have minus of A plus of A dot B is equal to 0 dot B is equal to 0. This minus of A plus of A, this is equal to 0. So 0 dot B is equal to 0 by 1. Since we know from 1 A dot 0 is equal to 0 dot A is equal to 0. So B dot 0 is equal to 0 dot B is equal to 0. Implies that minus of A dot B plus A dot B is equal to 0. Implies that minus of A dot B is equal to minus of A dot B. This proves second part. 3. We have minus of A into minus of B is equal to minus of A into B. Since A dot minus of B or A into minus of B, this is equal to minus of AB is equal to minus into minus of AB, as minus of A into B is equal to minus of AB by property 2. So minus of A into B becomes minus of AB. Now minus of AB, this is equal to A into B. Since R plus is a group, and in a group we have minus of A is equal to A, that is inverse of A is equal to element itself, this is equal to A. So this is inverse of AB, this is equal to A into B. Therefore, minus of A into minus of B is equal to A into B. Now question number 4 or part 4. We have A dot B minus C is equal to A dot B plus of minus C. This is equal to A into B plus A into minus of C by left distributive law. This is equal to AB, that is A into B plus of minus of AC, since A into minus C is equal to minus of AC. This is equal to AB minus of AC. Therefore, A into B minus C is equal to AB minus of AC. This proves fourth part. Remarks. 1. If R is a ring with unity and 1, that is unity is equal to 0, then since for any A belongs to R, A is equal to A into 1 is equal to A into 0 is equal to 0. We find R is equal to 0, that is R is a ring consisting of only one element 0, which is the additive identity, which is called the trivial ring. So in this case, R is equal to a ring consisting of single element 0 is called the trivial ring. So we generally exclude this case, and thus whenever we say R is a ring with unity, it will be understood that unity is not equal to 0 in R, because if unity is equal to 0, then it becomes trivial ring. Remarks 2. If n m are integers and a b elements of a ring, then it can be seen that n into a plus b is equal to Na plus Nb, n plus m dot a is equal to Na plus Ma, Nm of a is equal to n times Ma. A raised to the power m dot a raised to the power n is equal to a raised to the power m plus n. A raised to the power m whole raised to the power n is equal to a raised to the power m into n. Problem 1. Problem 1. Let R plus dot be a ring where the group R together with plus, that is R plus, is cyclic. Show that R is a commutative ring. Solution. Let R together with plus be a group which is generated by A. Let x, y belong to R. Be any two elements of R. Then, since R plus is cyclic, so x is equal to Ma for some m and y is equal to Na for some n. So, x is equal to Ma, y is equal to Na for some integers m, n. Now, x dot y is equal to Ma because x is equal to Ma and y is equal to Na. So, x y is equal to Ma into Na. This can be written as a plus dot plus a, because R is a group under addition. So, this is binary operation plus and this is m times. Here Ma means a plus up to a, which is m times, into Na can be written as a plus up to a. This is n times. So, this can be written as Mn into a square. This is equal to Nm a square, because n and m are integers. So, Mn is equal to Nm. Again, this can be written as a plus up to a, which is n times, into a plus up to a, which is m times. This is equal to Na n times a into m times a, that is Na into m. This is equal to y into x. Therefore, x y is equal to yx for all x y belong to R. Therefore, R is commutative. So, these are elementary properties of rings.